Okay, so today we're going to start section 9.5, which is basically graphing from vertex form. I know the section's called completing the square, but completing the square is not a topic that we teach until algebra 2. Okay, so it's another way to solve a problem, and it's a skill that can allow you to change from standard form, which we just learned, into vertex form. But we're not going to need this skill until algebra 2. So really all we're going to be doing is graphing from vertex form. So here's our vertex form: y equals a times, in parentheses, x minus h squared plus k, where a can't equal 0. If a was 0, 0 times this whole parenthesis would be 0. Therefore, this whole thing would be wiped out, and you'd have y equals k. That's why a can't equal 0, because that would not leave me with a quadratic equation. Now, this is very similar to the form that we graphed absolute value from, and y equals the absolute value of x minus h plus k. And we know the graphs are very similar because we know the absolute values get us the v's, where the quadratics will get us the u's. So there are some similarities. You're going to see when we get down to the steps from graphing that there are a lot of similarities between these two forms. So the vertex is given to you in this form, which is nice. So when we get down to the steps below, it's going to make it a little easier to graph. HK, which is given to you in the equation, is your vertex. The axis of symmetry is the vertical line going through the vertex, which would be x equals this h value. As far as the horizontal and vertical translations, I would probably get into this a little more if we were in the classroom, but I'm going to kind of slide through this, comparing this to the parent function, because I'm not going to be available to answer questions on it. This information typically would not be on a quiz or a test anyway. If a is greater than 0, then the vertex is a minimum. That means it opens up. Same thing as if a was greater in standard form. If a was positive, it opened up. If a was negative, it opens down. So therefore, that vertex would be a maximum. This vertex is a minimum. Okay, now the steps for graphing, now this is where it's going to be very similar to the absolute value. Okay, first find and plot the vertex. The x-coordinate is always opposite of the sign in the parentheses. And what we kind of said when we did the absolute value, except this I'm going to obviously write our new form, our vertex form, is we switch the h, keep the k. So whatever the sign is in the problem, you want to switch the sign for the h, keep the sign for the k. We use these words switch and keep because switch has an h in it, k has a keep has a k in it. So we switch h, keep k. Okay, so once you have your vertex, all the other steps are exactly the same as standard form. We're going to draw on our axis of symmetry. We're going to find points 2 through 5. The vertical change is always a times the next consecutive odd integer. The horizontal change is always 1. And then we're going to draw in the parabola, state the domain and range. Okay, so now I'm going to do a video for each example.